Okay, so the first technology that we're going to talk about is a powder bed fusion offshoot called binder jet 3D printing. So this is a technology that operates very similar to an inkjet. So an inkjet printer, there is one line of ejectors that will eject ink strategically, kind of so it can make an image. This does the same thing, but instead of printing onto a piece of paper, it prints onto a layer of powder, either a metal powder or a silica powder, or even some kinds of ceramics, a lot of times polymers, and it will spray a glue. And then that layer will drop down, and then another layer of powder will be pushed over, rinse and repeat. So you're actually gluing layers of powder together. There are some upsides to this. So this is a low to no heat process. Oftentimes, the more variables we have in a system, especially a complicated system like this, the more prone to failure it can be. Without heat profiles to worry about, ramp rates, all of that, you have less failures when you're actually printing. This is, however, almost exclusively used for industrial applications. Kind of makes sense. It's very power consumptive. It's a big unit. We'll take a look at a video in a second. Like I said, different materials. We're not going to worry too much about the actual characteristics of the machines, but suffice it to say they can be pretty crude. It's not as fine as some other technologies are. That's right. Forgot that my PowerPoint is misleading. It's truncated here. So we're going to take a look at a video of binder jet manufacturing, just so you can see what it looks like when it's running. So let me go ahead and pick it up. All right.
Guys, this is using pretty similar technologies as what we've already talked about, but I want
technology of inkjet.
Aaron, is my sound coming through?
In this process, a liquid binder is selectively deposited on a powder bed with a print head. It is a growing process that allows the production of parts for the manufacturing, medical, and dental industries. This technique enables the production of metallic and ceramic parts, as well as sand molds for castings. To start the process, a 3D drawing is imported into the printer software. The powder to be used is placed in a dispenser, which ensures a constant supply during printing. First, a powder layer of a specific thickness is spread. Thereafter, the printing head, moving on 2 axes, projects the binder where necessary. Before moving on to the next layer, the solvent contained in the binder is evaporated by an incandescent lamp. The powder bed is then lowered and a new powder layer is deposited. Therefore, the production takes place in a series of steps that build the part layer by layer. When the cycle is completed, the binder is cured by placing the container in a furnace. The temperature and time depend on the type of binder employed during printing. After this step, unbound particles are removed to reveal the part or the mold. After this step, the sand molds are ready to be used in foundries. The metal and ceramic parts must undergo sintering, infiltration, heat treatment, or hot isostatic pressing before being used.
All right, so you have these post-processing steps that are necessary with binder jetting that aren't necessarily aren't needed with other types of 3D printing technologies. Okay, cool. So this is awesome. You can do some cool stuff with it. Where are you doing cool things with binder jetting? What industries does this apply to? The first one they kind of mentioned, which is medical. This is used a lot for dental implants, for things that need to be coated, but once they're coated with the post-processing, it doesn't really matter the strength profile or anything like that. So they use it a lot in dental applications. This is something that is used quite a bit in aerospace. You'll see a common theme, which is that pretty much all of these technologies are used all the time in aerospace. I think if these aerospace companies had their way, there would just be a hangar that was a 3D printer and it would just like print an entire plane and they could just fly it off, because pretty much everything is made with additive. With this binder jet technology though, what you'll find is that the mechanical properties are anisotropic or non-isotropic. I won't get too much into details, but because you have layers bound together with glue, even if they've been sintered in the case of metal or fused in the case of the polymer, you're still going to have different, I'll say, breaking points, to keep it general, in different directions of the material. So this is not going to be used for loading necessarily. It is used for non-load bearing parts or aesthetic parts even. Speaking of which, one of the areas that this is used quite a bit is in furniture. So a lot of companies, furniture companies now, their industrial engineers will use binder jetting to either prototype a piece of furniture, or in the case of something that is not going to be holding up a whole room of people, they'll actually print the final part. Unfortunately, might be missing one or two industries, but without the slides, it's, the old memory banks get a little fuzzy when you get old. If you want to become involved, if you want to get a job working with binder jetting, and generally speaking, going forward, any of these technologies, there's going to be a couple of things that you'll need. So as I said earlier, 3D printing in general is a scalable thing. So if you have a 3D printer in your garage or in the lab at school, or in the lab at school, you already possess a skill set that you can put on your resume, right? Pretty cool. That is going to be translatable to a career that you could get doing any of these things. So what do you need though? Depends on what you want to do. If you want to get a job utilizing these technologies in any of the industries that I mentioned or will mention, it's going to kind of be dependent on what those jobs are also requiring of you in the other duties. Most of the time, it's going to be mechanical engineering. A lot of these technologies are tended to by mechanical engineers in these positions at these companies. You're prototyping, you're designing and printing parts, you're checking for tolerances, for loading, you're running simulations. If you have an electrical engineering background, especially when we get into additive manufacturing for electronics, you might be on staff to maintain the machines. These are complicated machines. They require a lot of control inputs from boards. They have a lot of motors. You also might be just a technician. You might be someone who is working on the machines to make sure that they function correctly. Now, what if you want to be building these machines, right? You want to work for X1, or you want to work for Stratasys, you want to work for Desktop Metal. That's going to require, more than likely, if you want to be on the R&D side, something more akin to a higher educational degree, a master's degree. I've seen some companies, when I was doing research for this, just straight out require a PhD, especially when you are in the more, the deeper side of R&D. But if you're not, you can also be working on teams, trying to get the stepper motors to run smoothly, or make sure that the assembly fits correctly. There's other jobs that you can have at these companies making these printers. So just keep that in mind as we go forward. I'll highlight the industries that some of these technologies are used in. Think to yourself, is that cool? Is that something I would want to do? Is that something that I would want to pursue?